Art glass can be bent, shaped, and to some degree stretched over molds in a kiln to create an almost endless variety of forms. This lesson presents an introduction to slumping with a focus on commercially available ceramic molds. In this lesson, you will learn the definition of slumping, the characteristics of good ceramic slumping molds, how to prepare a ceramic mold, how to set up a project in the kiln, what to consider in determining a firing schedule, a suggested process temperature range, and how to monitor pieces that are slumping in the kiln. Slumping is a kiln process that uses heat, gravity, and a mold to bend and sometimes stretch glass into a new shape. Slumping is a relatively low-temperature process. It is done separately and is not combined with higher-temperature processes such as fusing. If you try to fuse and slump in one step by firing glass to a full fuse in a slumping mold, the resulting piece will be misshapen and likely stuck to the mold. Because slumping requires a cooler forming range, much texture from prior firings will remain. For example, shelf-side texture, as well as surfaces that result from a tack fuse, will be largely unchanged in a slump firing. In choosing a slumping mold, it is important to understand how different materials and forms behave as they are heated and cooled. When glass is heated, it expands, and as it cools, it contracts. Ideally, slumping molds should allow the glass to freely expand and, more importantly, contract without resistance. Ceramic molds expand and contract less than glass when heated and cooled. They are generally best suited for slumping into because upon cooling, the glass will contract away from the mold. Rigidized ceramic fiberboard also expands and contracts less than glass and is also good for slumping into. Stainless steel molds expand and contract more than glass as they are heated and cooled. They are generally best suited for slumping over. There are exceptions to the general guideline to fire into ceramic and over steel. For example, shallow, open stainless steel forms, which allow both glass and steel to contract without resistance, are good for slumping into. And ceramic molds with a gentle, simple curve allow glass which has been slumped over the form to contract with little resistance. Although not covered in this lesson, other materials can be used in slumping, such as fiber paper, kiln bricks, and molite. Commercially available ceramic molds are used by beginners and professionals alike. A well-made ceramic slumping mold should be made of durable yet porous bisque-fired stoneware that readily accepts primer. Have smooth surfaces which facilitate slumping and do not impart unwanted texture to the glass during the forming process. Have vent holes in recessed forms to allow air to escape from between the glass and the mold. And have uniform wall thickness to promote uniform heating and cooling. A slumping mold must be prepared with a separator to prevent the glass from sticking to it during the firing process. If preparing a ceramic mold with bullseye shelf primer, mix 5 parts water to 1 part dry powder. Apply 5 layers of primer, coating surfaces that will come in contact with glass. Use a natural hair, fine-bristled brush, such as a hake brush. Kiln dry the freshly prepared mold more slowly than you would a kiln shelf to prevent breakage. Fire at 500 degrees Fahrenheit per hour to 500 degrees with a 20-minute hold. A prepared ceramic mold will serve for many firings, provided the primer remains free of chips and scratches, which could cause the glass to stick. Mold profiles with gentle curves, which are fired to low process temperatures, may not need to be re-prepared for 30 firings or more. Steep-sided molds and molds with recessed details need more frequent re-preparation. Glass pulls minute amounts of primer as it moves across these surfaces. Such forms are often fired to higher process temperatures with longer hold times, which also disturbs primer. When a mold requires a new application of primer, buff the used primer with a soft, dry scrub pad to remove it. Wear protection to avoid inhaling dusts. Prepare and kiln dry the mold as usual. Clear the vent holes of primer and carefully remove any loose brush hairs prior to slumping. Store and handle primed molds with care to keep their prepared surfaces in good condition. When preparing to slump, especially in a front-loading kiln, you may want to center the piece on the mold outside of the kiln in order to get a better view. Often, however, you will be able to place the glass on the mold directly within the kiln. Position the mold, ideally in the center of the kiln and 2 or more inches away from the elements. Elevate it with shelf posts to promote even heating and cooling in the firing chamber. Before firing, verify that the mold and glass are level. Here is a suggested firing schedule for a 6 mm piece in a 10-inch square slumper mold. The first segment of the cycle encompasses initial heat and process soak steps. Heat at a rate of 300 degrees Fahrenheit per hour to 1180 degrees and hold for 5 minutes. The purpose is to heat slowly enough to avoid thermal shock and to reach the slumping temperature range. The second segment encompasses the rapid cool and the anneal soak. Cool the kiln as fast as possible to 900 degrees and hold it for 1 hour. Allow the kiln to cool at its natural rate with the door closed. The third segment is the anneal cool. Program the kiln to cool at the rate of 100 degrees per hour to 700 degrees. A hold is not required as the schedule transitions to the final segment. The fourth and final segment is the cool to room temperature step. Program the kiln to cool as fast as possible to 70 degrees. Allow the kiln to cool at its natural rate. After firing, the piece is conformed to the mold and has a smooth bottom surface. Most forms will slump in the narrow and relatively low temperature range of 1180 to 1250 degrees Fahrenheit. When more heat work is necessary, you may choose to increase the process temperature or simply increase the hold time at process temperature. Sometimes both adjustments may be necessary. We commonly hold at process temperatures within this range for over an hour, especially for molds with recessed areas and steep sides. This lower for longer approach to slumping reduces the amount of mold texture picked up by the glass and helps maintain a uniform overall thickness. Although these ball surface molds are similar in form, the larger one will slump with less heat work because the greater mass of unsupported glass will bend sooner. The smaller form will need additional heat work to conform to the mold. These molds are both approximately 10 inches square, but the curvatures and unsupported masses of glass are quite different. The square slumper, which supports the glass only by the corners, will slump with much less heat work. After heating to 1180 degrees Fahrenheit and holding for 5 minutes, the piece in the square slumper has conformed to the mold nicely, while the other piece has not. Greater heat work was required for the glass to take the shape of a square platter mold with a recessed area approximately 5 by 5 by 1/2 inch deep. The process temperature was 1250 degrees with an hour and 15-minute hold. Glass thickness plays a role in determining a firing schedule. Heat thicker pieces more slowly, especially those with varying thicknesses, to promote uniform heating and avoid thermal shock. Also, thicker pieces, due to their greater mass, may slump at lower temperatures than thinner ones depending on the mold. Also, consider the viscosities of different glasses. These samples were slumped in dropout molds using the same firing schedule. The French vanilla sample has a higher viscosity in the slumping range than the black sample, so the black sample slumped significantly more. The deep royal blue sample falls somewhere in between. Due to the variables involved, visual confirmation of slumping in progress can be very informative and helpful in determining future firing cycles. Wearing eye protection and natural fiber clothing, you may open the door of a front-loading kiln at temperatures above 1100 degrees Fahrenheit. Depending largely on the form of the mold, slumping activity will take place closer to process temperature. Once the door is ajar, open it just wide enough to view the glass for a brief moment. Open and close the door quickly to help maintain an even temperature within the glass body. Think about what you have observed and make decisions after the door is closed. If a piece has slumped before the process temperature soak is completed, use the skip segment function to send the kiln to the next stage of the firing cycle. If a piece has not yet slumped near the end of the process soak, add time to the hold and continue to fire until the glass has formed as desired. If you are not able to observe a slump in progress, remember that it is often much easier to refire and increase the heat work than to fix something that has slumped too much. Make detailed observations and take note